Hello and welcome to this channel. I'm Yuhao. Today I'm going to introduce a deep learning project developed by myself, which is on the customer churn prediction in the telecom industry. First, we're going to look at the problem I'm investigating. Telecom companies consider their customers as the most valuable assets. However, a challenging problem that encounters most companies in the telecom industry is the switching over of dissatisfied customers. This could seriously affect the profitability of telecom companies. Acquiring new customers is much more expensive compared to retaining the existing customers. So, strategic goal should be set to work on dissatisfied customers who intend to stop the service and leave the company. In this scenario, deep learning techniques can be employed to process the customer data, including the demographic data, customer service data, billing data, and so on, to predict potential churners so that effective business solution can be developed to retain the valuable customers. And data used in this project is obtained from the Data World website. As we can see from the snapshot of the data, there are 12,891 instances. And after remove the customer ID and record ID, there are 19 features and one target. Among these 19 features, data types include categorical data, binary data, and numerical data. And the data type for the target is binary. We should notice that in this data, it has imbalanced classes. As shown in the pie chart, we can see that only 14.1% of instances belong to the yes class. So when we train the models, we need to overweight the minority class. And I developed two models in this project for customer churn prediction. So the first one is an ordinary feed-forward neural network with 4 layers. And the second is a bit more complicated, which is a wide and deep neural network with embedding layers. In the first model, data processing steps include one-hot encoding on the categorical features, binary features, and target, and the standardization on numerical features. The activation functions used in the hidden layers are leaky ReLU. Sigmoid is used for the output layer, as this is a binary classification problem. Optimizer and loss function used for training are ADAM and binary cross-entropy. In the second model, categorical data are first processed by the embedding layers and the reshape layers. Then a concatenate layer groups them together with other input processed by ordinal encoding and standardization. This architecture makes it possible for the neural network to learn both deep patterns, use the deep paths, and simple rules through the short paths. The activation functions used in the layers in the deep paths are leaky ReLU, and sigmoid is used in the output layer. And different from the first model, SGD optimizer is used for training in this model. And finally, let's look at some preliminary results of this project. And here's the table of performance measures evaluated with the validation data. The baseline model is simply predicting all customers will not churn. And clearly, Model 1 and Model 2 perform much better than the baseline model in all of the metrics. Since this is an imbalanced classification problem, AUC for precision recall may be more appropriate. So in this sense, Model 2 is slightly better than Model 1. So this is the end of introduction. Thank you and bye.